Hello and welcome back. We're going to talk more about the dimensions of the matrix and locating an entry in the beginning of this video. So when I last did the video, Intro to Matrices, we talked about stating the dimensions of the following matrices, and then I asked you to find the location of the circled entry. For number 1 here, I have 1, 2, 3 rows. I think of rows like rowing a boat, and you would row it this way, not up and down, if you will. And then I have columns, like Roman columns, 1, 2, 3, 4. So this is a 3 by 4, and -3 is in the second row, and the 1, 2, third column. So my answer for number 1 should be a 3 by 4, row 2, column 3 is where -3, the circled entry is. For number 2, this is a 1 by 1, 2, 3, 4, and entry 1 is in row 1, column 4. Number 3, I have 1, 2, 3 rows, 1 column, and 5 is in row 3, column 1. And this last one, I have 1, 2, 3, 4 columns and 1, 2, 3 rows, and -7 is in row 2, column 2. All right, now I'm going to ask you guys to create some matrices. So for number 1, I want you to make a 2 by 3 matrix, and I want you to circle the entry in row 1, column 2. For number 2, I want you to make a 5 by 1 matrix. Circle your entry in row 3, column 1. For number 3, I want you to make a 1 by 6. Circle your entry in row 1, column 6. I'd like you to pause the video now and try these, and then in 5, 4, 3, 2, 1, I'm going to give you the answers. If you did this correctly, you should have the following. Now, I didn't tell you what to put your entries as, so if you look here, I just have number, so you should have any number. You can have like 1, -1/2, 0, whatever you'd like here. So I have 6 entries ultimately, 2 rows, 3 columns, and in row 1, column 2, it would be this guy that you circled. Here's your answer for number 2. You should have the middle guy circled. And here you should have this. And if you notice, if you would multiply these, this tells you how many entries you're going to have. So 6 here, 5 here, 6 here. They're just arranged in a certain way because of the matrices. All right, now we're going to move on to the actual new stuff today. Today we're going to talk about adding and subtracting matrices and also doing a simple multiplication called scalar multiplication. So our objective today is to add and subtract matrices and to learn how to scalar multiply. The first thing you need to know when you add and subtract matrices is there's one big rule. They must be the same size. Must be same dimension, same size. Same size. If they're not going to have an entry to match up with an add, which is really the key to adding and subtracting matrices. So for the first one here, I have an adding example. This here is a 2 by 2. I'm going to add it to another 2 by 2 because in row 1, column 1, row 1, column 1, the 7 matches the 1 and as position-wise goes, and all I do is add this together. So I take this 7 plus this 1 because they're in the exact same position, and the math I'm going to do is in between them, and it's going to give me 8 as that row 1, column 1 answer of their sum. So now I have -2, which is in row 1, column 2, and +2. Now when I add these two values, one is the positive, one is the negative, so they actually cancel out, and I put 0 in their entry place. Now I have 4 here. Put a triangle around it the best I can. And I'm going to add that to row 2, column 2. I'm sorry, column 1's answer, row 2, column 1. -4 matches where 6 is, and they're going to add together to give me 2. And then I have finally 5 and 5, which are both in row 2, column 2. Row 2, column 2, and they match up, and when I add those two values together, I get 10. Hopefully you're like, that made sense. That was easy. Because subtracting is pretty much the exact same thing. So when you subtract, you're going to be matching up again. And again, these are 2 by 1, 2, 3, 2 by 1, 2, 3. And you're just going to match them up in their position and do the math of subtraction. Now, if you're the kind of person that can remember to change the sign, that's great. But you'll see me do this a lot, where I do like a chain reaction. So I'm going to take this guy here, and instead of subtract, I'm going to change it to add, but that's going to have a chain reaction over here. Everybody that was positive, I'm going to make negative, and everybody that was negative, I'll make positive. This is an option. You don't need to do this. I just tend to do it because then I don't have to worry about anything other than adding. So now, -9 plus -9 is -18. And 2 and -1, if I add those up, I'll get 1. And 1 and -3 will give me -2. And 0 plus 4, love 0 added to anything because it's just the anything. -5, +5, remember I changed it to adding. I didn't change the math, I just changed the look. And then 8 plus 16 is 14. There's 3 examples down here for you to try. If you'd like to pause the video and try those before I go over the answer, feel free to at this time. All right, first example. I have a lovely 2 by 1 added to a 2 by 1. This is great. Everybody matches up. So when I do my answer, I'm going to also end up with a 2 by 1. So I can even put my brackets waiting. So 2 is where 3 is. 2 plus 3 is 5. -3 is where -2 is. Add those up, I get a 5, but it's negative. So now I'm going to move on to, and I'm done there. Now I'm going to move on to number 2. In this case, I have row 1, row 2, column 1, column 2. Now, here I have 1, 2, 3, 4 of these lovely rows in one column. They are not the same dimensions, so this does not exist. This is not possible. You can write any of those options. Not possible, not same dimensions. Does not exist. D and E you can write. Any of those I would accept. All right, let's go on to the next one here. Hard to pick a color. Let's go orange. This is a 2 by 3, and this is a 2 by 3. These match up beautifully. We are ready to go. Now you might be like, what? There's decimals, but it's still the same exact thing. My matrix is already waiting. I know my answer is a 2 by 3. So, it is subtracting. Everybody here is positive, so I could keep subtraction if you'd like at this point, or I could just plus negative. Since nobody is going to have a sign change, I'm just going to keep them and not change it to plus and minus unless you'd like to. So, 0.5 minus 0.5, they would cancel out. 0.2 minus 1.2, this guy's larger. He's getting subtracted. The 2's will cancel out. It'll just become -1.0. 1.0 minus 2.0, that's going to leave me with the negative being larger. This minus that is 1.0. 0.75 minus 0.75 is 0. 0.3 minus 0.1 is 0.2. And 0.8 minus 0.5 will give me 0.3. So that's adding and subtracting. I hope you think that's very simple. Speaking of simple, I'm actually going to throw in something I just like here. These are word problems, which sound intimidating, but it's matrix word problems, so we're going to start with basics. Jan sold the following amounts of flowers in the month of June and July. How many, here's our key word, total did she sell? Total implies we are summing them up. So all I have to do are add these two together. Nothing crazy. These are a square matrices, my favorite when they have equal rows and columns. So I'm going to take this 86 plus 95, and that will be 181. I'm going to take 79 plus 78, and that will give me 157. I'm going to take 55 plus 65, and that will give me 120. And finally, 56 plus 68, which will give me 124. Okay, so not a bad one. Let's go to the next one. Chris sold newspapers and lemonade all summer long. Below are his sales for the first 2 weeks of July and August. What matrix will represent, and you notice I put it nice and bold because this is something we need to think about, his change. Change is not totaling it up, it's trying to see what happened from one month to the next. Did my sales go up? Did they go down? So we're going to be subtracting. And here's the really thing that we need to think about. When I do this change, I'm going to take August minus July, the most current minus the past. So I'm going to be taking and actually subtracting 1, 10, 43, 115, and 41 from my July matrix there, or my August from my July. Most current minus my past, because I want to see if my sales went up, down, or stayed the same. So these are all positive, so I'm not going to change this sign because that would be a lot of writing I don't need to do. 112 minus 110 is 2. 60 minus 43 is 17. 112 minus 115 is actually, the 115 is larger, -3. And 75 minus the 41 will be 34. So in looking at it, this gives us good information. It lets me know that my sales went up where it's positive and down where it's negative. Okay, so last thing I'm going to do is scalar multiplication. You are going to love this because it reminds you of your good friend distributive property. When you have a number outside of a grouping, instinct is distribution, and it should be. You just are like, everybody gets this 8. So 8 times 1 is 8. 8 times a half is 4. 8 times -4 is -32. And then I have this 8 times -1/4. When you do fractions, you multiply by the top, divide by the bottom. So if I do this, it'll be 8 times -1 is -8, divided by 4 is -2. If you have a calculator, you can type that in as well. All right, this, again, I'm just going to do distribution and get these lovely answers. Nothing crazy. I'm running out of time here. I'm looking at my clock. And I would like you guys to work on the following from that first worksheet that I posted to Google Classroom. There are these lovely problems here. 2, 3. Oops, I put my answers there already. I don't want you to see those. And I will post the answers later in the next video, so that you guys can check your answers, and then we'll move on to some algebra with matrices. That video is going to be next. All right. Happy adding and subtracting and scalar multiplication with matrices, and see you in the next video.